We're now going to start our discussion of Java streams. And this is one of the key focal points of the course. We're going to start first by talking about Java streams as a concept. Then we'll focus on Java sequential streams. And then we'll focus on Java parallel streams. For assignment number 2, you need to understand Java sequential streams and then use it in conjunction with the common fork join pool in order to get your program to run in parallel. So let's start by talking about what streams is. We'll talk about the structure and the functionality of streams. So we'll also talk about, in addition to sort of the fundamental elements of streams, the evolution of streams over time. They've added some other stuff since Java 8 when it first came out. So speaking of Java 8, the Java Streams framework was first introduced into the Java class library in 2014 in Java 8. If you take a look, you can see a description of what's new. There's a lot of neat, cool new stuff in Java 8, including functional programming features, including Java Streams. So a stream is essentially a pipeline of so-called aggregate operations that process a sequence of elements that are sometimes referred to as values or data. They're often implemented as objects, but they are commonly referred to as values or data for reasons that will become clear here shortly. So what is an aggregate operation? An aggregate operation is a so-called higher order function that applies a behavior parameter to every element in a stream, or potentially every element in a stream. Higher order function is just a highfalutin way of saying a function or a method that takes a method or a function, or in this case, a behavior, which is either going to be a lambda expression or a method reference, or an object or something. This allows us, this use of behavior parameterization simplifies dealing with changing requirements, because we can keep the flow of operations constant and then change the behaviors. There's a funny picture here that is amusing for anybody here who's ever worked on government contracts. There's the little dinghy on the back that says original contract, and then there's this bigger yacht-like thing that says change order. In government acquisition programs, if you have to make changes to the original contract, the contractor can ask for extra money. So here the dinghy was the original contract and the change order was the changes that occurred. So we can make it easier to cope with changing requirements. It doesn't cost us an arm and a leg like it would if you were doing government contracting. A stream is conceptually unbounded, which means it can flow forever, like some kind of video stream from a camera that conceivably could flow forever. Although in practice, streams are very, very, very commonly bounded by practical constraints. Most notably, you often start out with some data structure, some collection of some kind, like a list or an array or whatnot, and then you turn that into a stream. And because a list or an array starts out with a fixed size, the streams are often fixed size in practice as well. But conceptually, they're unbounded. You can think about a Java stream as being an implementation or a realization of the pipes and filters pattern from the POSA 1 book. There's a pattern-oriented software architecture book series. I authored or co-authored many of the books in that series. And the very first one, which I did not have an involvement with, but these are friends and colleagues of mine, talks about the pipes and filters pattern. And this pattern is very common. And the purpose of this pattern is to divide the tasks in some application into multiple self-contained data processing steps, and then connect these steps via some kind of intermediate data buffers to form a data processing pipeline. And you'll see there's a whole slew of different variants of the pattern, but this is a common one. Anybody here who's ever programmed with Unix and the Unix shell would be familiar with the concept of pipes and filters, because you can take the output of one program and pipe it into another program. So same kind of idea. There's other examples of that as well. We're going to use this example, which you can get here in the EX12 project, in my Java 8 folder, in my Live Lessons GitHub repository, in order to demonstrate some stream features. And this particular example prints each character in Shakespeare's Hamlet play that starts with either an uppercase or lowercase h, and it will consistently capitalize each of those names and then sort them. So that's what this particular stream does. We'll walk through each of these things in a second. So let's talk about the evolution of streams. So streams have evolved a bit over time. The latest version of Java, or later versions of Java, added a bunch of new operations. For example, there's this concept of a so-called teeing collector, which we'll talk about later in the course. There's some concepts of various short-circuiting operations called take while and drop while. These were added in, take while and drop while, I believe, were added in Java 9. The teeing collector, I think, was added in Java 12. And there was also these other features that we've talked about very briefly called reactive streams, which adds pub/sub support, and that came in Java 9 as well. We'll talk about some of this stuff later in the course, especially in the context of Project Reactor and RxJava, so you'll get a chance to play around with that later. So that's the end of the overview of Java streams.